Now we will see the inventory cycle, or seeing a diagram here. In this diagram there are three triangles are there. The bottom line, which is called a timeline, and this each triangle is having a y-axis line. This y-axis line is the quantity of order. So the Q is on the top. We first order the material this much of quantity at Q, that is the top point of this triangle. When you are using the material continuously every day, the materials get exhausted, and slowly it makes a slope and it comes to the x-axis line. So at a point, that is on the timeline, after some time, so many days after or so many months after, this slant line will come and touch to the timeline. Suppose it got a touch to the timeline, it means you doesn't have any stock anymore. You have exhausted all the stock. So after a few months you exhausted that stock. Now how you are going to make the production? They can't be able to produce the production after a few months. You will have to wait further for the ordering of the material and receiving of the material. This should not happen. That is the inventory cycle. If you make a perfect inventory cycle, you never face a problem of out of stock. You can see one is quantity on hand at the left side, that is highest value at Q. Then the material is getting slowly exhausted in a slant line, and you can see a dotted line here. We call it as a reorder point. So we are keeping some stock from the reorder point to the timeline x-axis. This much of material we are keeping in stock, and at a point, at the dotted line, first dotted line, vertical line, we place an order. Then when you place an order for receiving the material, it will also take some time. So after passing this time, we receive the order. We call this time as lead time. That is the time between the placing the order and receiving the order is called lead time. In this way, we are going to complete a cycle. That is, in a year there are three triangles. In a year, that is, each triangle consists of 4 months. The another is 8 months. The third one is 12th month or less than 12th month. Like this, if you construct an inventory cycle, you will successfully able to produce the production without any stock out. Now we will see how this EOQ model works in detail. You are seeing a diagram here. In this diagram, x-axis, this is a timeline T, and y-axis, it is from 0 to 900. Just consider this y-axis is the tons, 100, 200, 300 tons, 400 tons, 500 up to 900 tons marking is there. So what we have done, first we have ordered 800 tons of material. Then we began to use this material every day. From this 800 tons, a slant line goes on, began to come down. At the point, that is at 400 tons, when it reached, there we have taken a point on the x-axis by drawing a vertical line, and we have ordered the material. It has taken some time. Immediately the material doesn't receive. So we have ordered again 800 tons of material. It received it. At the timeline, after some time, it has been received. So the vertical line which we have drawn from 400 tons to the timeline x-axis, and the material received, that is 800 tons, we have drawn another vertical line to the timeline x-axis. So we got 2 points. We got 2 points. The distance between these 2 points is called lead time. This much of time it has taken. So now we have the stock of again 800 tons. So again this same cycle has been gone through, and we are ordering every time as 800 tons after some time. So the same cycle has been continued throughout the year. So there is a one point at 400, that is x-axis 400 line, we call it as reorder point, that is R is equal to S plus DL. Now we will see the costs associated with inventory. The following costs are applicable in the inventory system. 1. The item cost, that is production or purchase cost. 2. The ordering cost, that is setup cost. Number 3. The carrying cost or holding cost. Number 4. The shortage or stock out cost. All these costs are associated with the inventory system. Now we should know how to calculate the total cost. The total cost is equal to annual carrying cost plus annual ordering cost. So the total cost TC is equal to Q by 2, that is quantity divided by 2 into holding cost, plus D by Q, that is demand divided by quantity and the stock out cost. If we calculate it, we will get the total cost. Now you are going to see the EOQ model cost curve. This is a graph drawn on the basis of the annual cost, the order of quantity, and from which they are obtained the optimal order. In this graph we can see, that is the optimal order, the total order quantity,